I'm going to start this video by just reading this little paragraph here. It says the exponential growth model A of t equals a naught e to the kt, where k is greater than 0, assumes uninhabited growth, meaning that the value of the function grows without limit. So if we're talking about that growth model here, which this is back in lesson 3, we have these two graphs here. We have our exponential growth model and exponential decay. When I have that growth, it's just going to keep growing forever. It never stops growing. Same thing with the decay. When you have a decay rate, it's going to never stop getting smaller and smaller and smaller. Now that we are going to a logistic model, it says the logistic model can describe situations where the growth or decay of a dependent variable is limited. They are limited by factors such as living space or food supply. So here is your models of these here. Now, kind of a popular thing that you will see is when you're talking about like animals in the wild, right? If you start with some deer here, they're going to start populating and populating. It's going to be kind of slow at first, but all of a sudden, once there's enough deer and they're all populating with each other, that is going to rise really quickly and really fast. What would be a reason that that would start leveling off and the growth would start decreasing? The growth won't start decreasing. It just is increasing in smaller and smaller increments. And that could be food, right? If you have too many deer, now they're all struggling for food, and so that growth is going to slow down. A big one is 2014. What did we just experience 2, 3, 4 years ago? We had 2020 COVID hit. Same model right here. It started off slow. You had a case here, and a case there, and a case there, and then all of a sudden, it's starting to spread, and now everybody you know has it. Your mama has it, your aunt has it, your cousin has it, your best friend's boyfriend has it. Everybody had that COVID-19. But then all of a sudden, it's going to start leveling out. Why? It's going to end hosts. We eventually got shots to help us. It eventually stopped having new bodies to get into because our immunity was rising. We had better ways of preventing it by wearing masks and such. And so eventually that's going to start slowing down. And now we don't hear about as many people having it. But did that many people have it? Yeah, all these people here still had it. But that growth is starting to slow down because there's not as many bodies and stuff. Okay. So these are very applicable in the world, right? So here is my formula or my logistic model, and we're not going to get into a lot of like what A and B and T stand for. Well, T is probably time, right? Time T. But the big thing about these is this top number here, okay, which is represented by C. Now, C in the textbook calls it carrying capacity, which kind of makes sense. CC, we represent it with C, carrying capacity. But your homework's going to refer to this as limiting size. It depends on what textbook you read. I've also seen this being referred to as limiting value or even upper limit. But no matter what terminology we're talking about, this number here represents the maximum number. And so you can see that that horizontal asymptote here, that those are going to be approaching. So let's kind of use this model here. Example 6 says the number of people in a small town who are reached by a rumor about the mayor and the intern, ooh, how juicy, is given by n equals where t is in days. So part A wants to know how many people knew about this rumor when it initially started. So when it initially started, we're talking about t equals 0. So let's plug that in. And what are we going to get? And again, we're talking about people, so we're going to round to the nearest whole number. But if I put this in my calculator, I'm going to use my alpha y n over d. we have 10,000 over 1 plus 2,000 e to the negative 0.8, and my time is 0. So 4.99, very close to 5 people. So when this rumor started, there was 5 people. So how many have heard this rumor by the end of the 7th day? So now we're talking about our t equaling 7. So now plug in a 7. If you've already typed this one in, we're just arrowing up, changing our time from 0 to 7. So after 1 week, starting with those 5 people, now 1,191. So 1,191 people now have heard this rumor about the mayor and the intern. How much do you want to be one of those people? Okay. And then lastly, what is the maximum number of people that could hear this rumor? So it's not using the terminology. It's not asking what is the carrying capacity or what is the limiting size, but what is that maximum number? It's talking about this number here. So my maximum number is my C, which is 10,000. 10,000 people are the maximum amount of people. And why is that? Because that's how many people are in this town.